All right, love this one. It's a tricky one. Hold on here. All right. They're going up at a constant speed, so there's no change in kinetic. We would just put the same kinetic in at the front and the back, and then we just cancel out. So we know there's work done, there's applied work by pulling you up the slope. There's also work done by friction. Now let's leave that sign at plus because we don't know yet, and the algebra will take care of it. Because it's not a force or a distance, we're just finding the total. And all of that gets converted to potential energy because you're being dragged up a hill. If we know the applied and we want to solve question mark for work of friction, we would know the work done by friction equals the potential energy. Now here's where it all comes out, right? The work applied, that applied work of force over distance, that's pulling us in the direction of travel. So we're going to go mgy minus force times distance. Now I didn't have to put any signs in. The algebra took care of it, so careful there. All right, the mass of the dude is 80. Gravity's still 9.8 meters per second squared. The y change, you're going up. We only want the height. You don't want the length because gravity only works in the y. That's a big mistake students make. And now I'm going to subtract off that 340 newtons. Now, the 340 newtons works on the whole 120 listen to me, 120 meter long slope, but it's only 30 meters high. This is what gravity works on. This is what the applied force works on, because I got to get you up the hill. All right, so 340 newtons times distance, which is 120 meters, yes? And let's punch this first number in. 80 times 9.8 times 30 is 23,520. We're going to subtract off 17,280. And the work done by friction, that's what all of this is equaling. Once I put that into my calculator, I get a negative 17,280 joules of work done by friction. Don't mess with the signs. The algebra takes care of the signs. What was that? The algebra takes care of the sign automatically. Woo woo. Now, 2 works. It's the first time we've ever seen that. That seems like a good test question. Bye-bye.